Hello class, so once again we're going to be looking at quadratic functions this week. Today we're going to be honing in on properties of quadratic functions in standard form. I've already provided you a template for your Cornell notes, so just follow along with the video and just make sure you write every single thing down because you will need this to refer to at a later time when we go through example problems and problems in which you will practice finding and identifying those properties. Okay? So without further ado, just stay tuned. Alright, so at the top of your paper, you are going to write the topic, which is properties of quadratic functions in standard form, along with today's date, which is the 23rd. Okay. Once you have done that, you're going to write down the essential question. And the essential question that we're trying to ask is, how can I define, identify, and graph quadratic functions? Okay. We're going to have questions and key components throughout this video. So the first question that we want to ask is, what is the axis of symmetry? The axis of symmetry is a line through the vertex of a parabola that divides the parabola into two congruent halves. Once you have written this down, you need to draw the diagram of the graph and use a ruler so that it is neat. Okay. And so, just like the definition says, it's a line through the vertex of the parabola. The vertex is always going to be at the center of the parabola. Okay. Dividing it into two congruent halves. So if you were to fold this parabola at the line in which it divides it, both sides should match up perfectly. It should match up perfectly, okay? And your vertex is always known as h, k. This just represents two constants, two numbers in place for your vertex. So it can vary. It can be not any number, but it's subject to be any number, depending on where the parabola is positioned in the graph. Okay? And your axis of symmetry is known as x equals h. So if you find out what h is, then chances are you have found the axis of symmetry. Okay? So, moving right along. The vertex form of a quadratic function. There are two forms for a quadratic function. The first one we're going to look at is the vertex form, but what we're really dealing with today is the properties of quadratic functions in standard form. So we'll get to that in a minute. But the formula looks just like this. F of x equals a times x minus h to the second power plus k. Okay. We're going to look at an example of how we identify the axis of symmetry if we were given a quadratic function that was written in the same vertex format. So here in this example, you can go ahead and write this down. F of x equals 2 times x plus 2 to the second power minus 3. Now, just looking at it off the top, you would think that the answer for your axis of symmetry, x equals 8, h is 2, but it's not. Notice the signs are different. You have a minus here, you have a plus here. So we have to rewrite the function to where we can see exactly what number it is. And so remember when you learned in middle school about double negatives becoming a positive, so we're just rewriting x plus 2 as x minus negative 2 so that we can see that our axis of symmetry is in fact x equals negative 2. And because h, this is known as our h in the formula, so because h equals negative 2, the axis of symmetry is also x equals negative 2. Okay? Now we need to ask ourselves, what is standard form? What is standard form? We know what the vertex form is. What is standard form? Standard form is written as f of x equals a times x squared plus bx plus c, where a cannot equal 0. So the leading coefficient for your first term can never equal 0. It can be any other number other than 0. That's all that means. Okay? So, there is a way in which you can convert vertex form to standard form. And the way that we do that is, you see how this is written in vertex form? If you can recall the rules of exponents that you learned probably in 8th grade, that whenever you have a power raised to the second power, an exponent raised to the second power, that means that you are multiplying whatever is in parentheses or whatever the base is this number of times. So we just multiplied it twice. And if you see something like this, I hope you remember the FOIL method. If not, I will explain it at a later time, but due to time constraints, we're just going to move right along. So if you rewrite this out, this is the same thing as x minus h times x minus h, and you just bring everything else down. And then you would use distributive property, meaning you're going to multiply this a times everything inside the parentheses. A times x squared, a times a negative 2xh, and a times h squared. You'll multiply that out, and then you'll just bring the k down at the bottom. You'll just attach that to the bottom, because you're not going to multiply a times k because k is not included in the parentheses. So that's why you just bring it down. Okay? All right? And ultimately, standard form is written